so we are going to discuss. We have discussed, you can say, electronic configuration and how can we predict the chemical properties on the basis of electronic configuration. Okay, so today we are going to discuss. Today we are going to discuss the periodic trend. Okay, periodic trend means that you have to you can say the trends in melting points and the trends in boiling points, or you can say what is the trend of structure and bonding, and also the ionization energy. So let's do first the ionization energies. So and then also the atomic radii. Okay, ionization energy depends on the ionic radii, like the, you can say, atomic radii of different atoms of different elements. So let's suppose if I am going from left to right, what do you think? What do you think? Atomic size increases or decreases?
If you're going left to the right, then it would be the atomic size would be or the rings around the shells will increase, but then will it decrease the atomic size?
So, so you are saying that atomic radii, decreases as we go from left to right. As we go from left to right. Okay. So, when we go from left to right, so that number of shell remain the same. Let's suppose we have sodium whose proton number is 11, and this is chlorine whose proton number is 17. So sodium is having 3 shells. In the first shell it's having 2 electrons, like that. This is the nucleus of sodium. This is having 2 electrons in the first shell, and in the second shell of sodium it's having 8 electrons. Okay, in the second shell of sodium it's having 8 electrons, and then you can say that in the third shell of sodium, how many electrons would be having?
Because it has 11 altogether, it will be 2 and then 8 and then 1.
Exactly, so that should be 1. So in the third shell it would be having 1 electron. Okay, so it's having only 1 electron. This is the sodium. And if we discuss the configuration for, you can say, the chlorine, obviously the proton number for chlorine is 17. So I can say that it's having 7 electrons in its outer shell. 7 electrons in its outer shell. Okay, so if you can see this, both elements are having 3 shells, 3 shells, 3 shells, and 3 shells. 3 shells and 3 shells. So, but the sodium is having only 1 electron in its outer shell, and chlorine is having 7 electrons in its outer shell. This is the difference between sodium and chlorine. So, some students think that their atomic radii should be the same, but in the nucleus of sodium there are 11 protons, and in the nucleus of chlorine there are 17 protons. For simplicity,
because as you go down
exactly,
left to right, it actually just stays the same. Wouldn't the atomic radius not be staying the same? So it would just, why would it decrease?
Yes, that's what I'm going to tell you. Let's suppose it's having 11 protons in the nucleus and it's having 1 electron in its outer shell. Obviously, attraction between 11 protons and 1 electron, that would be the weak attraction as compared to the attraction between the 17 protons and the 7 electrons. So that attraction would be stronger. So I can say that due to the stronger force of attraction, the size of chlorine is smaller as compared to the sodium. And also we have a term that is called shielding effect. Can you tell me what is shielding effect? What is shielding effect?
So shielding effect is like as the
Like shielding. This is shielding. Screening effect.
shielding effect is like inversely proportional to ionization energy. So
Yes.
basically, as the shielding of the thing of the shell increases with more shells, then that means that the ionization energy decreases because the more shells that there are, the electron in the last shell will be easily lost. So the ionization energy is like
Yeah,
decreasing.
basically, repulsion between electrons. Shielding is nothing but the repulsion between electrons. Okay, shielding means that the repulsion between electrons, repulsion, repulsion between elect inner electrons, repulsion between inner electrons. As you know that sodium has 10 inner electrons. In the first shell, it was 2, and in the second shell it was 8. And if we talk about chlorine, in the first shell it was 2, in the second shell it was 8, the same inner electrons. I can say that if we are going across the period, like I mean to say from left to right, if we are going from left to right, so the shielding effect remain the same, the shielding effect remain the same, but the outer electron increases. So due to this, there would be stronger static force of attraction between the nuclei and the outer electrons. So due to this, I can say that chlorine would be having a smaller size as compared to the sodium. And the same reason for, you can say that as we go across the period, the atomic radii decreases. Okay.
Yes.
Yes. Okay. Then what is ionization energy?
Ionization energy, is it like the energy to make an atom lose or like attract electrons?
Only lose, no
Yeah,
attract,
lose
only
electrons.
lose. Exactly. So
Yeah.
basically, this is the required, energy required to remove 1 mole of electron, to remove 1 mole of electron from 1 mole of a gaseous atom. 1 mole of a gaseous atom to form, to form 1 mole of 1 mole of 1 plus ion. I mean to say that, let's suppose we have sodium metal. As you know that sodium is in the solid state, we cannot remove electron from the outermost shell of a solid atom. Remember, this is a conceptual thing. You cannot remove electron from the outermost shell of a solid species. Always remember, you are supposed to convert this sodium solid into the sodium gas first, because then otherwise you cannot remove electron. When you have converted this sodium solid into the sodium gas, then you would be able to remove 1 electron from the outer shell of a gaseous sodium atom to form this sodium 1 plus ion in the gaseous state.
Yeah.
So yes, we have removed 1 electron from the outermost shell of a gaseous atom, that is sodium. And ionization energy is always. Can you tell me it should be endothermic or exothermic? Yes.
So losing an atom.
Exactly. It's losing electron.
So losing electrons would be exothermic.
Exothermic.
No, endothermic, sorry.
Endothermic.
Yeah, that's what I meant.
Exactly.
Sorry.
Yes. So always endo, because in the definition I have mentioned, that energy is required. That energy is required. Energy required means what? So basically, you have to provide energy. so that it can absorb your provided energy, it can remove its electron, and that's it. So let's suppose we have magnesium that is in the form of gas already. As you know that magnesium is in group 2, so it can lose 2 electrons. But remember, one by one, according to the definition, 1 mole of electron can be removed from 1 mole of gaseous atom to form 1 mole of a cation. Once you have removed the first electron from the outermost shell of a magnesium atom, then now you can also remove its second electron to become Mg2 plus gaseous cation after removing one more electron. Finally, it's having a +2 charge because this is in group 2, so that's why it's having +2 charge. That's it. So this was the first ionization energy, and this is the second ionization energy. So generally, generally we can say that like the second ionization energy is greater than the first ionization energy. I mean, let's suppose this is the first ionization energy of magnesium, that is 748, that is 748 kilojoules per mole. And once you have removed first electron, it is converted into this form. Then I am going to remove the second electron, that is the second ionization energy. So this much energy is required to remove its second electron. Can you explain why the second ionization energy is greater than the first ionization energy? Yes.
Because the first ionization energy removes the first electron, but then as you go into the next electron, it has a more stronger attraction to the nucleus as you go further into. That means that the electrons closer to the nucleus will have a higher ionization energy, and the second ionization energy was greater because it's close to the nucleus.
Okay, yes, good. So means that when we have removed the first electron from the outermost shell, so you are saying that the after removing one electron, atomic radius is going to decrease. Means that the force of attraction between the nucleus and an outer electron is going to increase. So the size shrinks. When the size shrinks, obviously the attraction becomes stronger. So it would be very difficult to remove the second electron. And same goes with the aluminum. If you have aluminum, this is in the form of gas. First, you have removed its one electron, then it becomes Al plus gas. And then you do, like you're going to remove its second electron. So aluminium becomes Al2 plus cation. And then you are going to remove its third electron, then it would be coming Al3 plus ion in the form of gas.
Do only ionization energy only go up to third ionization energy?
Sorry?
So it can only go up to third ionization energy?
Yes, because no, we cannot remove more than 3 electrons.
Yeah,
this is the extreme case, exactly. Okay. Then what's the trend? What do you think if we are going from left to right? So the ionization energy should increase or decrease. What do you think?
The first ionization energy is not that strong, and the third ionization energy is the most strongest.
No. I'm saying that let's suppose if we talk about the third period, and you know, third period starts from lithium, then sodium, then potassium, then lithium, no. Sodium, then magnesium, then aluminum, then silicon, then phosphorus, then sulfur, then chlorine. I'm asking that if I'm going from left to right, so what do you think? Like the ionization energy is going to increase or decrease? Yes.
Will it decrease because there's more electron? No. Yeah, will it decrease because there's more electrons then?
As you told me that atomic radius decreases. So remember, when atomic radius decreases, you know, atomic radii, atomic radii is inversely proportional to the
Ionization
ionization
energy.
energy. If the size is going to decrease
Yeah,
across
then
the
that means
period,
ionization energy increase.
exactly. But remember, if you can see this, uh, this is sodium, then we have magnesium, then aluminum, then silicon, then phosphorus, then sulfur, then chlorine. This is the sodium, then this is magnesium, okay, then this is aluminum, this is aluminum, then we have silicon, then we have phosphorus, then we have sulfur, and then we have chlorine, and then we have chlorine. As you can see that, the overall ionization energy is going to
Increases.
increase,
Yeah.
but with few exceptional cases. The first exceptional case is magnesium and aluminum. If you can see this, this is going to decrease. Overall increases, but what about this and this? Magnesium and aluminum and phosphorus and sulfur. The ionization energy for aluminum should be greater than magnesium, because I told you that the ionization energy is going to increase. So the ionization energy for aluminum should be greater than the magnesium. But in fact, in reality, if you can find out the ionization energy for the aluminum, so you would see that the ionization energy is quite lower than that of magnesium. Can you explain it? Why the ionization energy for aluminum is lower than that of magnesium? Yes.
Is it because um is it because they have the I'm not sure.
Okay, let me tell you him. So you are supposed to write down electronic configuration first, okay? Like the proton number for
So
the magnesium is
magnesium
12
is
and this is
12.
13, right? Yes,
Yeah.
exactly. So what would be the configuration for magnesium?
Like as in 1s2.
Yes. And then
2s2.
okay. And
2p6.
then okay. And then
3s2.
exactly. That's it. And what about aluminum? This is 1s2,
1s2, 2s2,
2s2, then
2p6,
exactly, and this is 3p1.
3s2, and 3p1.
Exactly. So if you can see this, this is fulfilled. Its 3s orbital is fulfilled. What does it mean? It means
Oh,
that this is the more
is it because
stable.
aluminium and then sulfur have not fully stable
Yeah,
um
yeah, 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 yeah. You can
subshells?
say yes. You can say that because stability depends on the orbital. Whether you have full filled orbital, whether you have half filled orbital, and whether you have partially filled orbital. If you can see this in magnesium, this is 3s2, 3s2, 3s2 is full filled, more stable. And if you can see the outer orbital of this aluminum, this is 3p1. You can notice that this is the fifth orbital. You can notice that this is the 1, 2, 3, 4, 5. This is the fifth orbital, which is away from the nucleus. It's loosely attracted. And also you can say that they are experiencing, like 3p1 is experiencing a repulsion due to these electrons. Like in short, I can say that this 3p1 orbital is further away from the nucleus, okay, and is more shielded due to these four orbitals. It's more shielded, so it's loosely attracted. So the low energy is required to remove its outer electron as compared to this magnesium. If you can see this magnesium, this 3s2 is experiencing the the lower repulsion, because you have only three orbitals
Yes.
which are creating the repulsion. But in this case, there are 4 orbitals which are creating the repulsion between this 3p1 and the nucleus of this aluminum atom. So obviously this 3p1 is loosely attracted towards the nucleus, so we can remove its outer electron easily. This is the reason we can say that the ionization energy for aluminum is smaller than that of magnesium. Are you getting my point?
Yes.
Good. So what about this? How can you say, how can you explain why the ionization energy for sulfur is lower than that of phosphorus? As I told you that the ionization energy is going to increase across the period. So theoretically, it is supposed to be, I can say that the ionization energy of sulfur should be greater than that of phosphorus. But in fact, in reality, when we have checked the ionization energies of phosphorus and sulfur, then we came to know that the ionization energy for sulfur is lower than that of phosphorus. Can you explain it? The same reason you are supposed to first write down the configuration, and then you would be calculating which one is smaller and which one is higher. Yes.
So sulfur is actually lower because it doesn't have a half filled or fully filled subshell for the last one, which makes it unstable. So this is why the ionization energy is less than that of phosphorus.
Okay. Like me, you mean to say that sulfur is 16 and no, phosphorus is 15 and sulfur is 16.
Yes.
Three P3 and then
And phosphorus is half filled, and the magnesium on the other one is fully filled, so they're more stable.
good. And this is of 2 marks. You told me for 1 mark. What you would
Can
be
you write
writing
down
for
what
the
we meant
second
to,
mark?
what we're supposed to say, if that's okay, if you
Okay.
write it down?
Yes, see this. This is half filled, which is more stable. This is partially filled, which is unstable. Why this is
Yes,
unstable?
because
If you can draw
the
this
subshell is not
orbital,
half filled or full filled.
1, 2, 3, and then 4. This is showing spin pair repulsion, which is making it unstable. You have to mention it this point. You have to mention this point. This is very important. You have to mention this point that they are going to experience spin pair repulsion due to the presence of the 2 electrons in the same orbital. So obviously, which is making it unstable. So due to this, I can say that the ionization energy for sulfur is lower than that of phosphorus. Okay.
Yes.
And what about this? What about this? How can you say that which one is smaller and which one is higher?
So now 1s2,
1s2.
2s2,
Okay.
and 2p3.
Okay.
Whereas oxygen is going to be 1s2, 2s2, 2p4. Because the
Exactly.
nitrogen is half filled, it's more stable than that of oxygen, which is partially filled with which is not half or completely filled.
Good. Okay. Then moving towards, okay, what are the factors? Like I'm supposed to tell you, this is a part of your syllabus. What are the factors on which the ionization energy depends? Like let's suppose if I'm going to give you 2 examples, lithium versus sodium, and you can say the sodium versus chlorine. So I'm going to ask like you can say which element is having the lower ionization energy and which element is having the high ionization energy. So what the points you are thinking to decide to tell the different ionization energy of different elements? Let's suppose you have lithium whose proton number is 3. You have sodium whose proton number is 11. So, can you tell me which element is having the higher ionization energy and which one is having the lower ionization energy? And what are the factors that you are
Lithium would have a
thinking?
higher ionization energy because it has um a smaller atomic
Smaller.
radii, which means that it will have a larger
Exactly. So I can say that the first
ionization
factor
energy.
is, I can say that the first factor is, I can say that the first factor is the atomic radius.
Yeah.
Am I right? Exactly.
Yes.
And what about, and what about this?
And you can also say another factor is shielding effect too.
Good, nice. Shielding effect. Good. Right. What is supposed to be the other effect?
Is it charge of the nucleus?
Good. This is called the nuclear charge.
And what about the distance between the nucleus and the outermost shell?
The same thing.
Oh yeah.
So means that these are the factors that you would be considering while the examiner would be asking you to you can say compare, to have a comparison between the two ionization energies of the different elements. Okay.
Okay.
Yes, exactly. Okay, then these are the factors that you would be considering always when the examiner would be asking. Okay, then moving towards a structure and bonding. Moving towards structure and bonding. You know, we have like from left to right, obviously, when we are going from left to right. So let's suppose sodium, then magnesium, then aluminum, then silicon, then phosphorus, then sulfur, and then chlorine. Okay, and then chlorine. So, what would be the structure of and bonding of sodium, and then of magnesium, and then for we have chlorine, and then we have silicon, then we have phosphorus? Can you tell me this?
Can you repeat that one more time?
Like, let's suppose if I ask, what is the structure and bonding of this sodium? What is the structure of, what is the structure and the bonding of this sodium metal? So can you tell me the structure and bonding?
They're metals.
Okay, nice.
So then what
So
do you
this is a
mean by
metallic, giant metallic lattice.
yeah, but wouldn't yeah, you can carry. And then the metals all the way up
What type of
to
bonding it has? What
aluminium.
type of bonding it has?
Metallic bonding.
Exactly. Good.
Wait, what is it? What is the sodium bonding with?
Basically, you know, sodium is a metal and metal always loses electron. Let's suppose this is a particle of metal, that is the sodium. This is a particle of metal, that is the sodium. And we have a lot of particles, obviously, just like that. And then just like that.
Yes.
And just like that. Every atom is going to lose its electrons since this is metallic bonding. everyone is going to lose its electron just like that.
Oh, no, like it will be a sea of delocalized electrons.
Yes, sea of delocalized electrons, exactly.
Wait, won't in the circles it be positive? Yeah.
So,
And then is
uh,
magnesium and aluminium the same?
yes, magnesium is having 2 plus charge because
And
this
then
is in group 2.
aluminium will have 3.
Exactly. Aluminium would be having plus 3, okay?
Okay.
So, this is a metallic bonding. So, metallic bonding means they have a metallic lattice structure, just like this. And this is called the giant metallic lattice
What
structure.
spec point is this? 26 or 25?
Exactly. 26.
Okay.
25 and 26. Basically, in 25 and 26, they are going to discuss the trends. Okay.
Can you label it 25 and 26 next to the sides?
I'm supposed to label it?
No. Can you write when we do answer spec point 25, can you write 25 next to it? Then when we answer spec point 26, can you write a small 26 next to the exact
Okay. This is 25 basically.
Okay.
Okay.
So not 26.
26 basically is ionization energy. I have explained it. 26 is ionization energy that I have
Oh, can you
explained.
go up and label the ionization energy 26?
Yes.
Oh, can you send me this exact slide after?
I have sent you the total, but I will be sending you the same, okay?
No, but can you send me this one because it has the numbers on it?
Yes. Okay. I will be
Thank
sending you
you.
this as well.
Thank you.
Okay. Okay. What about magnesium? It should it be the same or did something
It's the
different?
same with +2 charge, and then
Exactly.
the aluminium is the same with +3 charge.
Exactly. What about the silicon?
Silicon, phosphorus, and sulfur and chlorine are all non-metals, so they will be either covalent bonded.
Silicon is covalent bonding.
Or it will be it's non-metal silicon, or it will be ionic
It's a
ionic
metalloid.
or
You
covalent.
know, silicon is a metalloid, and silicon exists in the form of giant structure basically, right? So giant covalent structure. It's a giant covalent structure because silicon is not going to lose 4 electrons. Silicon is not going to lose 4 electrons. It would be the giant covalent structure. And what about the phosphorus, sulfur, and chlorine? What do you think? Phosphorus, sulfur, and chlorine.
The charges of them.
This is non-metal, right? This is
Yes.
non-metal.
So they have minus charges.
This is non-metal. And this is also.
So will it be covalent or ionic? Because it might be non-metal and
Always,
metal.
always, always, this is a covalent because, to be ionic, it should be combined with the metal. But right now, we are not going to do any chemical reaction. We are not going to combine it. We are just going to discuss like the different atoms, like the different elements. Okay. So individually, the phosphorus is non-metal. So obviously, it would be having the covalent bonding. But remember, phosphorus exists in this form. This is the stable form of phosphorus.
Oh, wait,
Stable
because there's
form.
four of phosphoruses.
And then stable form of sulfur is S8.
Oh, wait, why?
Sulfur in the single state, it's unstable naturally. So it combines with other sulfur atoms to make it more stable. So I can say that when the sulfur is more stable, so it's mean that its formula is uh, like the P4 and S8. So when they make bond with each other, so they just uh, have a more stability as compared to the single one. Rather than this, all elements exist in the single state, like sodium, magnesium, aluminum, silicon, phosphorus. Like phosphorus is going to exist in the form of P4. Always the four atoms of phosphorus exist. So because this is the stable form of phosphorus, and same goes with the sulfur as well. So can you tell me the type of bonding? Can you tell me the type of bonding?
Will it be ionic then?
For ionic, you must have a metal. There is no metal. There is no metal.
Wait, what are the PS and Cl bonding to, or are they just what bonds they have in them?
Yes, let me tell you. Let me tell you this. As I told you that this is the phosphorus. So phosphorus means that you have four phosphorus.
Yes.
So this is a covalent bond. This is a covalent bond.
So within phosphorus, there's covalent bonds. Yeah.
Exactly. And
Okay.
it's a simple
No, I thought they had to bond with
molecular.
something, and then I thought they had to bond with another um
Oh,
element. That's
okay.
why I
You're
was a bit
thinking,
confused.
yes,
I
you are
understand now.
thinking that it's going to make a bond with someone else, right?
Yeah.
But this is not so. This is not so. And this is phosphorus. This is simple molecular structure. And then we have sulfur, S1, S2, S3, S4, S5, S6, S7, then S8.
Yes.
This is also a covalent bonding. This
What
is
has that
also a
got to do with
covalent bonding.
ionization energy?
No, we are not going to discuss the ionization energy. We have discussed the trend of ionization
Oh, okay.
energy.
I understand that
Okay.
now.
Yes, good, 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 good. And then these are the, you can say, uh, bonding and structures of different elements if we are going from left to right. Are you getting my point?
Yes.
Good. And then sulfur also exists in the form of this S8, and this is having a covalent bond. So the covalent bond means that this is also having a simple molecular structure. So what do you think about chlorine? What is this? What do you think about chlorine? What is
Chlorine will
this?
also be a non-metal, so it will have covalent bonds too.
Okay. So, like, can you tell me the stable state of chlorine? As I told you, the stable state of phosphorus and sulfur.
How do you know what it will be?
Yes, this is chlorine. This is simple Cl2. This is a halogen. It's in group
Yeah.
7.
So will it just be two of them then? CO2.
Yes, in group 7, you have
Because they're all
all the
diatomic. Yeah.
diatom. Exactly. So F2, Cl2, Br2, I2, At2, they all are diatomic. They all are diatomic, right?
Yes.
And also this is having a simple molecular structure. Can you tell me any giant covalent structure if you remember? Any giant covalent structure if you remember?
Um, I'm not too sure.
Diamond,
Oh, yeah,
graphite,
diamond, graphite, and
exactly,
graphene,
silica. Yes, silica also,
and
silica as well.
fullerenes.
Chlorine is a simple molecular, it's not a giant.
Oh, okay.
Yes. Okay, so these are the structures and bondings that you need to remember. You need to memorize it basically, right?
Yeah.
What do you think regarding the melting and boiling points? They are going to increase or decrease? What do you think? Melting point, yes.
I think that
This
as
is
what
very
increases,
easy.
sorry? As what increases?
Melting and boiling point. Let's suppose melting and boiling point across the period if you are going from left to right. Melting and boiling point, MP and BP.
Will the melting and boiling point increase? Because you need more energy.
Let's discuss these three first
Yeah.
because these are metals. Then we would be discussing
Okay.
these non-metals. So first of all, we have to do a comparison between these three. First of all, we have to do a comparison between these three. Now you can have an idea that if you are going to have a comparison between the sodium and magnesium, so can you tell me which one is having higher melting point and which one is having a lower melting point?
Why do magnesium having a higher melting and boiling point? This is because that as you go as you go down, the number of like the
We are not going
charges.
down. We are not going
I
down. We
mean,
are going from left to right.
yeah, if you go across, the number of electrons increases. So then you need more um higher temperatures to break the bonds. Also, metallic bonds are very like um are very strong intermolecular forces, so we need even more energy to break them apart.
Wait. Basically, in magnesium, it's having +2 charge. In
Yeah,
magnesium, it's having +2 charge. So in its lattice structure, if you can see, there are more electrons because one magnesium loses 2 electron as compared to the sodium. One sodium loses 1 electron. One magnesium loses 2 electrons.
yeah.
More electrons, more electrostatic attraction. If you would
Can you
use
write
the
this
word
down, please?
inter, yes, okay. So let's suppose, I can say that sodium loses 1 electron while
Yes,
magnesium loses 2 electrons. So in its lattice structure, in a lattice structure, due to more
yeah,
electrons and Mg2 plus ion, there would be having a strong attraction, but electrostatic attraction. If you will say that, if you will say that this is intermolecular force, this is completely wrong. Intermolecular forces doesn't exist. Intermolecular forces don't exist in ion
oh yeah,
in ionic
yeah.
compounds and also in metallic diagrams. So strong electrostatic force of attraction.
Will the will the melting and boiling point increase because the
Yes,
more electrons?
yes, that's what I'm telling you, because the number of electrons are
Okay,
going to increase, and which would be affecting the obviously electrostatic force of attraction between the cation and the sea of delocalized electrons. And you know that as the attraction increases, obviously they would be requiring the more energy to melt and boil. So this is the reason I can say that the melting and boiling point increases from sodium to aluminum, okay.
yes,
Yes. Sodium is on the peak. Sodium is at the peak. It's having the highest melting point across the period. It's having the highest melting point across the period. Can you tell me why?
the which one?
Silicon.
Is it because silicon is like, well, it doesn't, we don't really know its charge. It's like in the line where there's four plus and four minuses. And is it because it has, did you say it has the highest charge? I can't hear you.
Yes. What are you saying?
Can you repeat your think question because I couldn't really hear you.
I was telling you that if we like let's suppose in the comparison of sodium, magnesium, and aluminum, it's increases from left to right, and silicon is on the top of the line because the silicon is having a giant covalent structure. Due to this, it's having the highest melting and boiling point. And then we have to do a comparison between these three: phosphorus, then sulfur, then chlorine. Do you have an idea, like if we are going from left to right, from phosphorus to chlorine, the melting and boiling point would be increasing or decreasing? Yes.
Increasing
Why?
because they have more electrons. So then you, when they have more electrons, they need more um energy to. like be bonded or gain or lose electrons?
Phosphorus is P4 and sulfur is S8.
Yeah,
More bonds, more electrons. More electrons is stronger force of attraction. A stronger force
yeah.
of attraction needs to be overcome with a with a strong
Strong
force,
amount of
with a high
energy.
energy.
Yeah.
Exactly. That's why the sulfur is having the higher melting and boiling point as compared to the phosphorus. But what about the chlorine? What about the chlorine? What do you think for chlorine? What it's supposed to be?
It will
It
be
should be
even
higher or
more
lower?
higher because as you
It should be
actually
lower.
it'll be
It
lower
should be
because it's diatomic
exactly. This
too.
is diatomic. Yes,
Mm.
now you are correct. Okay, so this is what the trend of the melting and boiling point, and also the structure and bonding across the period. Okay,
Yeah. This is all for chapter one if you have seen. Have you seen it?
sorry.
And I think chapter